guys. Um, so I'm going to ask a few questions myself. So how many of you guys use Netflix? Okay. What's the latest shows you guys have been watching? Just shout out. Luke Cage, okay. Quantico, okay. Stranger Things, yeah, that's a big popular one. Okay. Narcos, okay. Yeah, it, over time, even I'm losing sight of the originals that are coming out of Netflix, and some of the names even I don't know what they are. Can't keep up with them. So without much delay, um, I'm Vinesha. Along with me, I have John Sebastian Jonet, with JS. I never call him with his first name. I can't pronounce right. Um, Together, we're going to present Winston. In case you're wondering, the invite said Saili Karmarkar was going to present. She couldn't make it, so we're going to just pick it up and present. Um, Winston, by the way, in case you haven't guessed, is our auto remediation and diagnostic platform. You will, as part of the introduction, I'll go over the high-level overview of what Winston is, what it does, and what the business goals are. And then one of the feedback we got from our last meetup was, you guys wanted to learn more about the internals of how it's deployed, what's the execution flow looking like, and the internal architecture. So JS is going to help dive into the internals of it, and then hopefully show some aspects of live demo of what we have. And then I'll pick it up from there. And then the goal is to cover some of the learnings and challenges from, implementing and deploying Winston in the Netflix environment. Some ideas that hopefully you guys can pick up and not go through the same pains. And then share some stats and the road ahead, and then we'll take it from there. So before I kick off, what Winston is, I just want to give you guys a high-level overview of where Netflix stands and at what level are we applying this auto remediation and diagnostics. So a few interesting tidbits. Netflix doesn't own its own data center for its control plane, the plane that serves you the catalog, allows you to log in, stores all your bookmarks, and so forth. We have our own kind of our own CDN network, but I'm focusing more on the control plane side of things. Everything we do is on top of AWS on the control plane side, which means we don't have to deal with hardware. We just, I'll let AWS do all the hard work for us. We also have a full ownership model, which means our engineers are responsible not just for architecting and coding up the services that they build to give you the experience, but they also own the operational aspects of it, the deployment aspects of it, keeping the services healthy, being on call for your own services. We don't have SREs or operators for specific services. In total, I believe at Netflix, we have like 3 or 4 SREs, and they don't own any service. So what that means is there is always a conflict for an engineer here between new feature work that's being done or that needs to be done to move the product forward versus keeping the existing service up and healthy. You combine that with the scale and growth that Netflix has seen over time. We just released our Q3 numbers. We are at 86 million plus members across the world. And the high availability guarantee that we want to provide to our customers means there's always a conflict between operations and new feature work. So the way we solve it is we invest in tools and services to make the life of our developers much easier to do. Winston is one such tool. There are a bunch of other tools out there. A few of them are open source as well. Winston is one such tool targeting a niche use case within the operational world that every Netflix engineer faces. So that just gives you a high-level overview of the landscape. From an engineer's point of view, right? Imagine yourself owning a component, an application, or a service. You usually end up having monitoring on top of your application. You want to understand how the application is doing, metrics. On top of that monitoring, you will end up having alerting, right? Thresholds to define when should I actually start looking into when detecting something is bad on your service. And then in a lot of scenarios, what they end up doing, at least at Netflix, is going through PagerDuty or email, basically escalating the problem to the person on call, to the engineer on call. So where does Winston stand in this 1,000-foot view, right? So I forgot the more important detail. Now, when these events are repeated, as an engineer, you usually end up having a set of steps that you have either persisted in your memory or persisted in a runbook somewhere or in a tool or a service, and you wake up in the middle of the night and start executing those steps. So Winston is basically providing that support for you where as an engineer or as an on-call person, during same business hours, you provide that same runbook to the system, configure it for the same set of events or alerts that are happening in your operational world, and then the platform takes care of it, right? So in a sense, what we call tier 1, tier 0 support, the first level of support, we aim to provide that through software. Here are some specific business goals that we went after when we started looking at something like Winston, which was to help reduce your mean time to recover, right? The time from when an issue is happening in the system to when it's diagnosed, detected, diagnosed, and mitigated. We want to reduce and shrink that time frame as much as possible. We want to reduce risk of human errors. When people do things manually, especially when there are context switching from what they're doing to solving operational issues, they can make mistakes. Some mistakes can be very expensive. We want to avoid all of that. We want to, of course, reduce pager fatigue. The Mirantis guys talked about that as well. Keep our developers happy and not doing some stuff that they don't really like to do. And then Winston as a product is supposed to also, make you as an engineer just worry about your business logic of remediating or diagnosing. You don't have to worry about the infrastructure around it. And it'll make more sense when we go a little deeper into it. And then finally, we hope to provide or implement the best practices around runbook lifecycle management, and so that not everybody has to worry about that. This is the textbook definition. So Winston is an event-driven runbook automation platform. It is designed to host and execute runbooks in response to events. So yeah, so with that, I'm going to present to JS, and he's going to talk about the internals.
Everybody hear me okay? Testing the laser. It's not going to work. It'd be useful for. So how is it deployed? Now that we know what it's for, how does it work, and how do we make it happen? There it is. Is everything's clear? No question? Okay, now next. So the thing I want you to focus on first is the fact that we have region isolation, and the little green box is actually a Winston instance, and this is the MongoDB cluster. So you can see that we have we're deployed in 4 AWS regions, and we have region isolation. So the alerting system is also deployed in the 4 regions. So if an alert comes from one region, it's going to be handled by the Winston cluster in that region. So on the right is the actual Winston execution platform where we have all this logic happening. On the left, it's mostly the runbook, what we call Winston Studio, is what they use to edit their runbook. And that's the part that they're going to be mostly viewing. They actually don't really know what's happening here. That's the reason why our team is here, is to abstract all of this logic and just give them a nice little UI. They can put their code, and it magically happens to run in production and test and in dev. I'll go deeper when I talk about Winston Studio, the difference between dev, test, and prod, but that's mostly to give them a stage approach so that they don't have to think about, okay, I want to write this, but I don't want it to run in production yet. I'm not ready. So I want it staged before. The other thing that we have on the left is how the actual bits of the runbook gets deployed on the instance. So first, the user is going to have the Winston Studio UI, going to save their automation. When we want to deploy it and test, it's going to get automatically saved into Stash, which triggers, we don't see it here, it triggers a Jenkins job, builds it, which triggers another job that's going to push the bits to S3, which triggers another job that's going to push the S3 bits on all the instances. Why did we add S3 here? Why not just take it from Stash and put it on the instance? The reason why is because when we want to scale these clusters, let's say we have a surge of alerts in one region, we don't want to have a startup bootstrap dependency on Git. We're okay with the S3 dependency because of the number of nines they have. They have much more nines than we do actually. I don't remember how many, but tens of nines. It's pretty crazy. So S3 going down is, I've never seen it yet, so we'll see. Might happen, but at least it's going to be more stable than Stash. So that's the actual overview of the whole system. Now we can dive into one of these little green box, and that's where you see the orange is the StackStorm open source version, and the red is the Netflix component that we have that we're using, and the blue one is the AWS SQS service. So very similar to what we saw before from the other presenter. We have our alerting system that will send an event to SQS, and we have an SQS sensor that we wrote that will actually pull messages from the queue and start processing them through their rule engine and decide which action to run, which will actually interact with our Netflix ecosystem. So that's for the 10,000 view and the 1,000 view, and now for the actual Winston Studio, which is the UI I was talking to before. This is what our customers are actually more used to interact with. They don't actually, most of them don't even know that it's running StackStorm underneath it. We have tried to abstract it so that they don't have to understand how a rule is written, how the parameters are configured. So we're going to go to detail into that. It supports all the create, the read, the update, delete, execute, and the diagnose functionality that Winston does. And it tries to implement the best practices so that our user, our engineers don't have to think about auditing what to run where, the persistent logic of their automation, and what about security, authentication, authorization. It's also self-serve and scalable. As you've seen on the previous slides, there was multiple instances of Winston Studio running fronted by ELB. So now the interesting part. First, before I show the demo of what it looks like, the terminology packs is actually a grouping of automation. They're either related by one team owning it or by product owning it. For example, we can have a Cassandra pack, so everyone that has control of the cluster can use this pack. So it's the same logic as StackStorm. The action is the actual runbook that they're going to run to diagnose or remediate, and the event and inference source is what triggers these different runbooks. Now we all make a prayer to make sure the demo works. Oh, that works. Okay. So this is the UI that the customers are going to see when they log in. And they have all their packs that are displayed here, which are all Netflix packs. And for each pack, they're going to have a bunch of automation. So for example, if I drill into the Netflix Cassandra pack, we have a disk space critical process alert automation that we have here. So we can see here the code that they actually wrote, the Python action. All their logic is written here. And on the right, you can see Chrome. On the right, you can see my friend pop up on my. On the right, you can see the event source here. So you can see that there's 361 alerts that are connected to this automation. And this is the mapping that say, okay, if the alert contains this name, it's because it's Cassandra alert, and if it's one of the disk space critical alerts, it's going to trigger this automation. Here you can see all the parameters that the alert can contain, and the notification for on failures. In case this alert fail, we want this is one of their engineers going to receive an email. So that the actual automation is supposed to succeed all the time. If there's a failure, it's not a desired state. It's because there's either a bug in the code or another problem. We don't want the failure situation to be a decision making. If at the end of this execution they want to page someone, they're gonna call the function to page an engineer, and that's gonna still be considered a success. We can actually see on the top we have all the logic to save, run manually the automation, and the logic of promotion that we talked earlier. So the three stages are dev, test, and prod. So some of you might ask why dev. So The dev version is actually it's never triggered through an event, so it's not attached to any alert. So it's a way to very fast iteration on the part of the engineer. They can try something, save, and running manually. I won't do it now because not on this one at least. But let's say this one can be run safely. Another automation that we have here. Let's say I want to add a little world classic. Can save it. Takes a couple of seconds to do the commit on Git, and then I can click on run, and automatically I can have it run in the dev stage. The dev stage is still connected to the test environment. So we have test and prod, but the dev one is actually not attached to an alert. So it's kind of a pre-stage for them to be able to test it. In a couple of seconds, this is going to turn green, and we're going to know that this is complete, and I can see the detail of the execution, see the output, and the logging output if I guess the SCV error. And I can go deeper and see a bigger view of this execution. So this was very important for us to develop Winston Studio because it made the adoption of our product much bigger, because people were now able to very quickly iterate on their automation without knowing, okay, how does the YAML works for the rule? They didn't have to understand underneath it. They just have to say, I want to create a new parameter. Here's the name, the description, the type of parameter, is it required or not, and then add the parameter, and they can quickly iterate and work without having to understand the underlying infrastructure. And then you can see that this is a sample, so it's not deployed in test or prod. But if I were to take this and promote it to test, it would take about 5 minutes, and it will get deployed in all our. Earlier we saw all the Winston instances. In about 5 minutes, they'll get all this automation updated on their instances. And then when it's available, I can demonstrate it right now, but when it's available here, the promote to prod is going to be enabled. It's going to detect that there's a different version in test and prod and let you promote it to prod. So that's most of the big overview I wanted to give you to Winston Studio. I'm going to switch back to the presentation. The show you earlier about disk space was one of the remediation approach that we had there, but there's a couple of automation for false positive. They use it also for assisted diagnostics, so to be able to correlate with kernels, which is another system that we have to keep track of. It's auditing any changes in the cloud so that you can see in the past hour, here's whatever what all the infrastructure changes happen, all the instances are created or terminated, and they can correlate this information in their automation. And with that, I'm going to give it back to Vinny.
So I think in terms of learnings and challenges, right? There are a couple of tidbits of information I'm going to share. The first thing is about the patterns. Like, what kind of usage have we seen with the system at Netflix? Now, remember, Winston is a tool as a service. We don't own any of those use cases. We provide an interface, we provide the infrastructure, and we let customers play around with it. Right? So this has been the studio and the Winston aspects of it has been completely deployed. It's been almost a year now. And these are the common patterns that we've over time seen surface up. There are one-off use cases outside of that, but these are the majority of the use cases. The first thing is around false positive. I think Nikita mentioned really well that all alerts should be actionable, but it's difficult to do so. There is always a signal to noise ratio in your alerts. What we've seen is customers use, and by the way, when I say customers, it's all Netflix engineers. We are not selling this outside. We have seen our Netflix engineers use Winston to procedurally detect false positives in their events so that only the right filtered events pass through. This can happen when your underlying alerting and metric system does not have all the information. And so you make it a little more open-ended and then let events flow over into Winston. And then Winston can do all the additional checks to decide whether it's something you would want to escalate or you want to squelch right there. So that's a big bucket of use cases that we have. Diagnostics is another use case. The analogy I would draw with diagnostics, which is the second item here, is when you go to a doctor, you actually don't meet the doctor first. You actually meet a nurse. And the nurse would collect information about your weight, your blood pressure, your temperature and stuff, and even do some basic diagnostics on the data that you've collected and keep it all ready for a doctor to come in so that he or she can just jump into remediating the problem. By the way, LinkedIn has a similar product like Winston. They call it Nurse. Good name. So this is basically what I consider tier 1 support, where it's collecting all the information, it's doing some basic diagnostics, and then keeping everything ready for the on-call person to come in and then take it from there, doing all the grunt work. And then the next step after that is remediation, which is under some safe conditions, you want a system to procedurally just go and remediate the problem at hand. When you know exactly, or you can convey through your run book what steps needs to be taken, the system will take it for you. And so we have a bunch of use cases like cleaning up desk logs, restarting Spark jobs, Kafka jobs automatically. And then the last bucket is little more one-off, but it's the broker scenario where you already have your event source and then you already have your remediation or diagnostic service separately. Winston just helps connect the two systems. It does do protocol and data transformations, and then allows you to do one-to-many connections in the microservices world that we have. So these are the common patterns that we have seen that are being used at Netflix. Again, remember, this is all at the application level. We don't manage data centers, and so your results may vary. Here are some other interesting insights that I wanted to share. This is the first time I'm sharing it, so give me feedback whether these make sense to you or not. So one thing that we've learned within that 1 year is, the barrier for something like auto remediation and diagnostics is not technical. It's not a technical challenge. It's more of a cultural challenge. For example, if you have members in your team and your company whose sole purpose is to do the manual work for the company, there is a conflict of alignment, right? They are not aligned to automate their jobs out of the thing. You really want to question whether when you introduce something like this into your companies, into your teams, whether it's ready culturally to accept something like this. Is it ready to put that investment into automation to take that step forward? It's an investment because it takes effort to bootstrap and to put that effort in. There is a virtuous cycle. Once you get in that mode, you save time, which again allows you to add more, which saves time again. But the bootstrap requires a cultural shift. And in some teams within Netflix, we saw this pushback. An interesting nuance to that is what I call the problem of diffused cost, right? So, teams here at Netflix are their own on-calls. Imagine an engineer being on call for 2 days in a month, right? The cost for them to just slog through the 2 days, to be woken up in the middle of the night and keep doing manual stuff, is low, and they'll just do it just to get done and move on to the remaining part of the month and get the work that they want to do. But every person in that team paying that cost means it's a cost to the company. And so when you're trying to push for that culture, right, the way I saw it work in our company is to ask those hard questions, like why are we doing this repeatedly? Why are we doing this manually? To have insights into where and how much time is the team as a whole or a company as a whole spending their energies in. Like an interesting, like we use PagerDuty, and I often go look at PagerDuty analytics. There's a small tab for analytics there, which will tell you which teams are getting paged the most and things are getting escalated the most. And then you can start having that conversation. Sometimes the teams don't even know that across their members, they're spending a lot of time doing manual work. So yeah, so that's an interesting insight that I thought I would share out. The next is noisy signals. When you're doing stuff manually, you don't want to deal with noise. It's like a needle in a haystack problem. Humans are not built for solving needle in a haystack problem. More often than not, we'll just, let go of that signal and wait for some other signal, right? Noisy signals are sometimes important because it helps you catch issues much earlier. Now, there's a cost to it. It's the noise, right? You need something that can help detect and filter out those noise. It kind of aligns with the filtering of false positive scenario. What we have seen is once you have something like this available, more and more teams are interested in using this to filter out the noise and get to the real nuggets of events that are happening in your system. So, an interesting discussion to have is, do we have noisy signals that we would like to use to detect issues in our systems? And if so, this could be a good solution out there. The last one is an interesting one. I couldn't come up with a better name for this. So imagine a spectrum of software. On one end, you have, full control over the components. Could be software, could be data center, could be anything that you are owning and operating. You have built it, you have developed it, you know in and out of it, you have the expertise in your team to make any changes that you need to. On the other end of the spectrum, imagine working with a black box. Could be something like the internet or commodity hardware, right? Where you're buying hard disks from the commodity stores. It could be from an application layer perspective, open source software, which you haven't built on hand. You don't have the expertise to actually make commits and check-ins. What you've seen and what I've seen is in this spectrum where you have full control and you have very little control, something like an auto diagnostics or remediation platform is more aligned in this space. And the reason being, when you have full control, you are more likely to make the fix to the underlying issue directly versus trying to remediate or diagnose it from the outside. And that's the right thing to do. Now, there is a caveat to that, but in general, you want to target use cases where you have lesser control and you need patching or diagnostics from the outside to handle the scenario. We use open source software quite a lot at Netflix. We depend on the internet, and there are a lot of internet events that can disrupt the environment, which is completely out of our control. And so be aware of what scenarios are you targeting, and I think again Nikita mentioned this in his presentation. Focus on fixing it the right way if you can. If you can fix the product itself, do it. If you cannot, for whatever reason, is when you try to do patching and diagnostics from the outside. So yeah. So that was the usage bucket of how we've seen the systems being used. From a product perspective, the other thing I want to talk about is safety, right? Automation is all about taking instructions that humans follow and giving it to a machine to follow. What we end up not doing sometimes is, there are some behavior that humans have. We are inherently safe. We tend to survive. We are slow, which means we can't do mass damage really quickly, right? How do we take those human natures, which are sometimes useful, sometimes not, and transform it back into the automation space? It is sometimes forgotten, and things continue to work. You might have, when an event fires high CPU, terminate my instance. You're running Cassandra, you have this automation deployed, everything is working fine. Whenever there's a bad instance and CPU goes spikes, you kill an instance. Imagine some bug upstream, and all of a sudden you have all instances firing that we are out of CPU. You're going to lose data. You're going to have big issues there. So think about safety when you're automating something, and think about how you, put that into context so that you don't shoot yourself in the foot by, automating the wrong things. I'm going to beat the drum here. Usability is important. First version of Winston that we had, and remember, Winston was as a service to our customers, required people to know a lot of stuff, required them to set up their machines with a bunch of CLIs and internal cognitive information that they needed to know. It didn't fly. People, Netflix engineers have a lot of things that they own, and they would rather not add more to their load. So we had to, we realized after the fact that when you're providing something as a service, usability is really, really important. And so we had to spend quite some time building what you just saw, Winston Studio, to make people approachable to the product, to make people approachable to the problem space in the first. And finally, resiliency. I consider something like Winston or something like auto remediation and diagnostics as a very infrastructure level service. When things are burning, you want this system to be as much up as possible so it can, one, diagnose and remediate the problem. You don't want to burn while everything else is burning, which means that you have to really think highly about resiliency. What is the availability of your system? What dependencies do you have? A classic example is we were initially thinking, oh, we want to use Cassandra. Cassandra is heavily used at Netflix, and we wanted to use Cassandra. Well, it turns out Cassandra uses us to do their own remediation. So how is that going to work? Again, I'm not saying it's bad. I'm saying be aware of those dependencies and think about the failure mode scenarios and make those decisions. So for an infrastructure level service, resiliency is super important. And for something like auto remediation and diagnostics, you want to think about the worst case scenario and design around it. Recommendations to get started. I think the first one is don't reinvent the wheel. We started off by building our own prototype, and we realized, and I was talking to a few folks outside, we didn't have anything undifferentiated, right? So we then looked outside and we found StackStorm, and StackStorm fit our needs really, really well. So why reinvent the wheel? Why build something from scratch when it serves 90% of your needs? It's never going to serve 100% of your needs. It's unlikely, let me put it that way. Can you live without that 10%? Is it worth the cost of building your own and maintaining your own for a long term for that 10%? That's the thought process you have to provide. You have to think about. Start simple and iterate. This is something that we found value in. We also tell our customers, when you are implementing runbooks on StackStorm or on Winston, you don't have to think about all the possible scenarios. If there are 4 manual steps that you would like to automate, just do that. Don't wait for the whole scenario to be flushed out in your head. Chances are it's never going to happen. Allow experimentation. This is interesting. So we have what we call as a dev environment, which allows us to allows our customers to play around with the product and see what are the possibilities without, it is a more cocooned environment in a particular region within test that allows people to experiment and see different use cases. So think about that, especially when you're giving it as a service. Talked about usability, talked about culture. Last one, there are a bunch of teams, bunch of companies outside who are doing very similar work. Talk to us, like, these meetups are there for a reason. Use the expertise from others. Maybe you can help us be better. Maybe you don't have to go through the pains that we've gone through. So, talk to us. There's a Facebook team right here, probably signing you guys up, but they have had FBAR for quite some time, and we actually learned quite a few things when we attended the meetup at Facebook, learning about FBAR. So use this opportunity to learn, and hopefully, overall, we can reduce the cost of building something like this. I'm not going to spend too much time on the metrics since we are already out of time. The road ahead is all about adoption, adoption, adoption. We want to increase more usage of the system at Netflix, and we are learning and we are iterating. This is one of the projects that my team does, and we continue to focus on doing more. Usability, we are looking at polyglot support, allowing people to provide Groovy-based runbooks because Netflix is also a Java shop, and people like that. So deeper integration into the Netflix ecosystem. From a safety perspective, we're looking at resource isolation, which is making sure each action is run in a secluded environment. We've had unintended denial of service attacks because of one action taking over all the memory and causing all the other actions to kind of crash. So we're looking at how do we do resource isolation, security isolation, so that access is granted at an action level and not across the board. And then rate limiting, right? The safety aspects that I was referring to. So these are some of the more near-term areas that we want to go focus on. Some links and resources. There's a tech blog that goes into a little more detail about Winston that you can go look at and read more about on Netflix tech blog. StackStorm docs are all on docs.stackstorm.com. I find their documents pretty useful and thorough, so use that. And then reach out. Like I said, if you have any questions, ideas to discuss, we're always open to talk. And then, yeah, final pitch, I had to put it in. We are hiring for a senior software engineer. So if you know anybody or if you are interested, reach out.
Yep.
That's it. Question?
For the record.
How do you deal with the Chaos Monkey or Chaos Gorilla that you guys run there?
That's one of the services that Netflix engineers have to test for resiliency of their system. It's very rare that we conflict with that service, if that's what you're asking. Chaos Monkey and Chaos Gorilla is to think about, it's specifically targeting, instances going down. Like that's one chaos scenario that it targets. None of our scenarios target instances going down. That's something that has to be expected. Every service has to be resilient by default. They shouldn't need something like Winston for instances going down necessarily.
Do you have any plans to put the studio in the open source?
We would like to, but we don't have any plans, unfortunately. We're still focusing on the internal side. At some point, hopefully, we can focus on the external side as well.
To add on that, there's a couple of our dependencies are not yet open source. So when all of our dependencies is going to be open source, we'll be the last one. We won't have any reason not to, but right now it's not a priority. But the idea that the reason I made a demo of it is not to show here's a nice product that you can't have. It's more how to think about deployment of the runbook. The idea that we try to convey is here's how to make your customers, in our case, our engineer, understand the flow and don't have to decide how they want to deploy their automation. Kind of take that out of their hand and make it easier to use.
So one of the questions that I have is, suppose that I'm a Netflix engineer and I'm editing one of your remediations, one of your actions, right? Yeah. And I just go and I write some really obviously wrong code, not syntactically incorrect, but actually wrong. And then I just hit that save button. I hit promote to test, promote to master, and it gets pushed out. And it starts breaking stuff. How do you roll back? How do you prevent that kind of thing from happening? Is there a review process, canarying? What's going on?
It's freedom and responsibility is a big thing at Netflix. So the idea of taking save, promote is not recommended, of course. Most people are going to save it in dev, or hopefully run it, but sometimes they'll just promote it in test and let it run for a couple of days and then eventually promote it to prod. And as for reverting, we don't have a quick revert button, because the way it works, you can just go to Stash, copy the version you want, paste it back again, and then you have the safe version. We don't provide that yet because that's not a use case that we see often. But eventually that might be a problem if people start doing promote. The good thing is they at least have a 5-minute delay. So most of the time they're going to start doing something else and they forget that they just promoted that. No, it's not something that we experience often.
We've talked a little bit about canaries. We haven't gotten to it yet. What that means in this world, we haven't gotten to it yet.
Thank you.
That was something that we put in the first version before Winston Studio. We actually had the canary logic in, and we didn't see a big benefit of it for our customers. We didn't add that into the UI logic, but we had a different queue for canary, and we're saying just configure a couple of your alerts to go to that queue and let it run for a week. So we were supporting that use case. Right now we stopped supporting it, but the most of the automation is very simple. It might look at a local code. The one I showed you is just because this was the assisted diagnostics one that are mostly local code. But if these breaks, that's not a big deal. There's no remediation involved. Most of our remediation are restarting services, are cleaning up disks. So we haven't had any issues yet.
Hi. So one of the problems that I've seen with automation is that sometimes it ends up hiding certain symptoms, and you set up something to delete or fix certain things like disk space and all, but because it gets fixed automatically, it gets hidden by something new might be happening. How do you float up those issues? How do you make it more visible to people who are? Do you send some reports? Do you and kind of analytics?
Yeah, so what we have an analytics of what's running. So we know every time an action is running, we actually use our own monitoring system to also track the trend. So right now it's a manual process. Every week we check, and if we see something looks wrong, which didn't happen yet, but if something goes wrong, we'll probably contact them and say, by the way, this is going wrong. If that becomes more of a problem and people not expecting the automation to run as much, we can start putting alerts on the trend of automation based on, because it's our same, it's kind of a feedback loop. Our Atlas monitoring system is the one that triggers the alert, but we use also Atlas to monitor our system.
And we actually did prototype the Elasticsearch model where we wanted to make the analytics aspect self-serve, so people can automatically detect what actions, how their actions are running, which of them are failing, which of them are succeeding. We saw little traction on that. Maybe it's the maturity of the use case in our case. And so we just had a prototype and we didn't productize it. So, but the goal was every action run would send metadata to Elasticsearch, and then you would have a Kibana dashboard that any customer can go look and kind of play around with the data.
Given that it's been for a year, so and then there's like alerts which have been already received, right? Is there like, and then I'm going to the Winston Studio and I'm coding a new rule or an action. How interesting would be that I can kind of like replay through all the older alerts and then kind of like see that, oh yes, I mean, this is getting validated, or chronologically I can see that, oh, it's firing too many times. Is there any kind of beneficial, or how do we kind of look at that?
We actually add that in our backlog ourselves a while because we were thinking, oh, our users are gonna want that. So it's in our backlog, but it so far hasn't get any traction. We could go as far as 2 weeks because our 2 or 3 weeks, but that's the amount of live data that we have. But we haven't seen a lot of traction. But we thought about that because it's going to be very useful for the end user. They can actually try something and see exactly by backtracking it through time how it will have worked. But it hasn't been implemented yet.
Quick question. How do you see from your experience perspective the stability of the network which is underlying all these applications? And second part is there some kind of monitoring related to the capacity of the network usage, and maybe you are almost overrunning it, and how do you take proactive action to mitigate that?
So we run on AWS, which is a public cloud, and we actually don't monitor the network. If we start seeing network issues, we escalate to AWS, and then they have their own remediation and diagnostic modules to do that. That's one advantage of running in public cloud.
We do have a team that monitor the network, but it's going to be like big route going down or stuff like that. And individual instances having networking issue is rarely going to show up. They're going to show up because they're going to see other issues. They're going to have spike in latencies of their API call, and they're going to say, oh, maybe it's a bad instance, they shoot it and move on. But we don't have any particular stuff looking at IP stats or anything like that.
Do you foresee how much is the surge of the elasticity that you are kind of utilizing, and maybe it's just going to reach the ceiling soon?
I mean, how much network we can use?
Right.
Yeah. I mean, our networking team monitors that. They have alerts on top of the CloudWatch metrics that AWS sends in terms of the capacity of the network for our account. And yeah, we monitor that, we alert on that, we take actions on that. It's not something we personally deal with or Winston deals with.
We have alerts around everything in SMP for like TCP retransmit and all of these issues, but rarely people are going to look at these metrics to alert. They mostly look at their application metric as the real answer, because if they go, that it's kind of an iterative approach. At first, you start for low-level metric. You monitor CPU, memory, and network. If something goes wrong, you know something is bad. But as these alerts becomes more mature, they move into the okay, I'm expecting no more than these amount of errors. I'm expecting no more than this latency of my API call, and that's what they look at. And then they disable the CPU. Because sometimes CPU loads go to 8, but your application is responding correctly. So maybe that's not a big problem. So I don't know if that's answers the question.
Thank you.
In a way, the way we see it is that we can drop events if something starts to be processed and that particular Winston instance dies, that event will be lost. But the assumption is that our monitoring system will keep on sending the alert until the situation is fixed. So the next one will trigger, and that instance will die, and our auto-scaling group will start a new instance, and this one will start processing alerts. And since we have, in a way, we are HA, but we know have at least one guarantee. We can lose events, but eventually, if the alert condition is still valid, it's going to be processed. So we actually encourage people to make sure your automation is idempotent. If not, then you can have weird behavior. It can be processed twice.
Thank you.